So let me quickly recap on what we learned about agent so far. So the first point is agent should be able to take us from one place, that is one point, to another, and the agent should be able to add value to our life. And the second point is agent is capable of accessing the external tools and be able to make the decisions and come up with a plan. And we also learned agent should have memory, and an agent should be able to listen to the human feedback and rectify any mistakes. And we just learned that we convey to the LLM to use the tools by using the prompt. So that part is clear, right? So tools convert an LLM into an agent, and tools helps agents to interact with the external world. And now let's see how agents can plan and make decisions. Okay, so these two are most important things. The first one is understanding tools, and then ReAct framework. Okay, so we understood tools so far, right? Now let's understand what is ReAct framework. So ReAct framework is nothing but the underlying framework that helps agents to plan and make decisions. Okay, so we will deep dive into this. So let's understand why we need a framework like ReAct framework, right? So ReAct framework is the underlying framework that helps an agent to plan and make decisions. Okay, so let me take you to this research article. So this is the research paper, ReAct framework, so synergizing reasoning and acting in language models, right? So please go through this article, right, when you have some time. I will provide this in the resource section as well, so you can go through this article and get an idea on the ReAct framework. So essentially RE stands for reasoning and ACT stands for action. Okay, so reasoning and action. So by using this ReAct framework, agents will be able to interact with the external world and help agents to plan and reason as well. Okay, so now let's see how ReAct was born first. So we initially started with chain of thought prompting. So this is one of the prompt engineering technique. Chain of thought, that is COT prompting technique, helps LLMs to answer as if they are thinking and planning, similar to how a human does, right? For example, we have asked two questions here, standard prompting versus chain of thought prompting, right? So you can see the question here, Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? Okay, so the answer is 11, because 5 plus 2 times 3, so total is 11. So in this case, the LLM answered correctly. And then if you see the second question, the cafeteria had 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have? So with standard prompting, the LLM gave the output as 27. Okay, so which is not correct, right? Because total 23 apples, they used 20, so 23 minus 20, and then they bought 6 more again. So plus 6, 23 minus 20 plus 6, which is 9, right? But the LLM gave the answer as 27. Okay, so the LLM gave the wrong answer with the standard prompting. So that's why they introduced chain of thought prompting. So if you see the chain of thought prompting, here this is again the same question. So you can see the answer. Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls. So 5 plus 6 is equal to 11. So you can see the detailed answer, right? And then with the same question, here it is trying to give the cafeteria had 23 apples originally. They used 20 to make lunch. So they had 23 minus 20, which is 3. And they bought 6 more apples. So they have 3 plus 6, 9. The answer is 9. So you can see in the prompt itself, we are telling the LLM how reasoning is done. Then the LLM will mimic that in the response it predicts, right? So you can see in the COT prompt, we are actually showing the reasoning example. So the LLM can mimic the same when answering. And then when we asked a question, it is able to answer, right? So you can see the LLM provided the answer in a detailed way, as if the LLM is thinking and answering, right? So this clearly tells us that when we include thought process in the prompt itself, then the LLM will answer as if it is planning. And this chain of thought prompting technique proved that the LLMs are capable of generating the reasoning traces or generating the thoughts, right? So you can see as if the LLM is trying to think and then answer. So you can see that in the answers here. But the issue with chain of thought prompting is chain of thought prompting lacks access to the external world. So it cannot act, that is, it cannot take the action. Reasoning part is good, right? So the LLM is able to reason, but we also want LLM to take the action, right? In addition to reasoning. So to address this issue, we have the ReAct framework. So ReAct framework was built on top of chain of thought. Okay. So ReAct means LLM plus reasoning, which is nothing but chain of thought. And then we are also adding action. So that's why it is called ReAct, reasoning and action. Okay. And the way the ReAct framework does that is through a principle called thought, action, observation loop. TAO. So thought means the agent's LLM thinks about what to do next, planning and analyzing the problem state. And the action means based on the thought, the agent takes an action such as invoking a tool. For example, DuckDuckGo web search tool or LLM math tool, right? And the observation means the agent receives the result of its action, which is a new information to incorporate into its reasoning. So that is the thought, action, observation loop. So if we take the same iPhone example that we have seen before, so this is our example, right? So we built an agentic application by using LangChain. So let's say if we give the same example to an agent, the thought will be what it has to do. What is the latest iPhone model and its price in USD? Give me the price in UK currency. So the thought will be I have to check the iPhone price, and based on that the agent will take an action. Then the agent thinks, okay, let me do a web search, and then the agent receives an observation that the price seems to be in dollars. Also, please note that the agent will not stop after this first loop, and the agent keeps repeating this loop until the agent gets the correct answer. Okay. And in the second loop, the agent thought would be the price need to be converted from USD to UK currency. That is the second thought. And then the action would be, okay, in order to do the price conversion, let me use a calculator tool. And the observation would be price in UK currency, right? So once it gets the price in UK currency, the agent will be satisfied with this answer, and this loop repeats until the agent satisfies with the answer. Then finished chain, right? So this is the input we gave and this is the output we got. So if you notice here, you understand the difference between a language model and an agent, right? The language model, for example, ChatGPT, generates an answer and stops over there, whereas an agent keeps repeating the loop until it satisfies with the answer. So that is the difference between a language model and an agent. Okay. So once the agent satisfies with the answer, then it will stop the execution. So if you notice in chain of thought prompting, there is no loop as thought, action, observation, right? There is only thinking and then answering. It is thinking and then giving the answer. Whereas in the ReAct framework, the loop is happening, right? That is both reasoning and as well as action. So here actions are performed by using the tools that we provide. For example, use the DuckDuckGo search tool and do the web search, or use the LLM math tool and do the rate conversion, right? So the action is happening by the tools that we provided to the LLM. So that's why both action and reasoning is happening with ReAct framework. So you can see in this ReAct framework, an agent continuously interacts with the external world, right? And in the observation, we can have humans in the loop as well, and we can provide the feedback to an agent. Okay. So agents are LLMs equipped with tools. And using this ReAct framework, agents interact with the external world to add additional information into their reasoning. So now you get the difference between LLM and agent, right? So you can call this ReAct framework or Agentic AI or Agentic framework. That's the idea behind this framework. So both reasoning as well as taking the action. Okay. Now let's see another example to understand this thought action observation concept much better. So assume that there is a kid who went to a party, and assume there are 5 boxes here, and the kid has to find the box which has the toy. Okay, so here you can see the thought action observation loop, right? For example, let's say the first thing is kid goes to the first box, and then it observes there is no toy at the first box, and then the third would be okay, nothing in box 1, so the action is to go to the next box, that is box 2, and then again okay, there is nothing here, and then the kid knows it needs to go to the third box. So the kid finds the toy eventually in box 3. So just like how we human make decisions, agents are doing the same, right? And also another important point is agents need to have memory as well. For example, if this kid forgot that he already checked box 2 and forgot what happened at box 2 when he was at box 3, then he may need to go back, right? So that's why memory is important to remember the previous actions. That is, the memory of past interactions is very important. Similarly, if we go back to our iPhone example, if the agent doesn't remember the price in USD, then the agent cannot calculate the price conversion to UK currency, right? So the memory is important. So now we understand that agents interact with the external world and also have memory. Or agents can take decisions and make plans by using this ReAct framework. So where did we actually implement this ReAct framework in our code? So if you notice here, it is happening inside the prompt. Okay, so here you can see thought, action and observation, right? So the thought would be you should always think about what to do, and the action would be the action to take should be one of tools, and the observation is the result of the action. And if you see here, this thought, action or action input or observation can repeat n times. Thought will be I now know the final answer. Once you think you know the final answer to the original input question, whatever question we asked. So once the agent thinks that the answer is correct, so once the agent thinks that is the final answer, then you come out of the execution. The agent repeat n times until it finds the final answer. So everything has been given to the LLM in the prompt itself. So we are providing the tools or thought action observation loop, right? So that's why this prompt engineering is very important. Since LLM was able to understand the language very well, they implemented this framework. Okay. So without language models understanding the language, there is no meaning of this framework, right? So that's why we are providing the thought process inside the prompt itself. And we want the LLM to question itself until it finds the answer by repeating n times. So prompt engineering is very important when building agentic frameworks. And inside the prompt, we are defining the tools as well, right? So once we have the prompt, we define the tools, and then we created the agent by providing access to LLM, tools as well as prompt. So we are giving these 3 parameters to our agent. So once we provide LLM, tools and prompt, that will become an agent. And then we finally started executing this agent by calling this invoke method. So agents are nothing but glorified language models who have access to tools and have access to the external world, who can plan, reason and also can have memory. Alright, so with this you understood how to create an agent by providing an LLM access to tools and how to execute it, right? So in the next lecture, let's implement one other use case as well. So you will be able to relate to all the concepts that we have learned so far. Alright, thank you.